Hi guys, this is Julianne Arantes M. Carlos from grade 10 Patients of Marikina Science High School, and you can call me Ju. Hello, I am Nicole Faith B. Vidal of grade 10 Patients, and you can call me Nikki.
Hey guys, I'm John Kyle Aaron R. Lucenara from 10 Patients, and we're about to discuss distinct permutations. You can call me Kyle. Hi guys, I'm about to give an example to give you a simple background. Got the word I, and I chose this because there are two letters in the word that are the same. And we're gonna put a subscript. Here, I put a subscript so you won't let confuse yourself. And I'm about to put the number of arrangements available in the word I. We have 3 number of arrangements in the word I. Here, we have 2 different ways to write the word I, and we have 2 factors. So we're about to divide 3 by number 2. And we got equals 3. So guys, now we're done. I'm about to give you Nicole and Julianne to give you more infos about this.
So, hello! We are going to talk about distinct permutations. But first, what are permutations? A permutation, also called an arrangement of number or order, is a rearrangement of the elements of an ordered list into a one-to-one correspondence with itself. Ang permutation ay arrangement nga or ordering of a number of distinct objects. Distinct or distinguishable permutations. Okay. Consider all the permutations of the letters in the word Bob. Since merong 3 letters, there should be 3, it's denoted as that, and it is equal to 6 different permutations. Okay, so those permutations are BOB, BBO, OBB, OBB, BBO, and BOB. Now, while there are 6 permutations, some of them are indistinguishable from each other. If you look at the permutations that are distinguishable, you only have 3, which are BOB, BBO, and OBB. To find the number of distinguishable permutations, take the total number of letters, factorial. Divide by the frequency of each letter, factorial. Now, this is an example of a distinguishable permutation. A problem. Find the number of distinguishable permutations of the letters in the word MI, SSI, SSI, PPI, or Mississippi. So here are the frequencies of the letters. The letter M has 1, the letter I 4, S 4, P and P 2, for a total of 11 letters. Okay, so let's be sure that we put parentheses around the denominator so that we end up dividing by each of the factorials. So in total, there are 34,650 distinguishable permutations in the word Mississippi. The next example is find the number of distinct permutations in the word coffee.
We know that the number of permutations of some given string of length n is n factorial. However, we need to take into account the number of repeated permutations. We do this by counting the number of permutations of the repeated letters, in this case, F and E. Therefore, we have we have 6 factorial over 2 factorial is equal to 180. Here is another way to think about it. You have the word coffee and 6 blanks. So 1, 2, 3, 4, 5, 6. Choose. So, begin with E. Choose 2 of the 6 blanks and pop the E's in. So, lagay natin siya dito. E and then E. Yan. So, yan. This can be done in 6 choose 2 ways. By the way, this is a binomial coefficient. So, now 4 blanks remain. Place the F's in these. So, F and then F. These are 4 choose 2 ways to do this. 2 blanks remain for C and O. And so, dalawang ways din yun. So, you get in CO, CO. CO. Yan. So, wait lang. So, ganito siya. 6, choose 2. Then, 4, choose 2 is equal to 2 times 15 times 6 is equal to 180. Suppose that Dr. Quack Quack conducts research which involves infecting 20 people. 20 people with the swine flu virus. He is interested in studying how many actually end up ill. We name it ill as 1, I, and then how many remain healthy, H. How many arrangements are there of the 20 people that involve 0 people ill? So, in this case, we can readily determine that there is just one way. The sequence would look like this. Alternatively, we could use the formula for counting distinguishable permutations. The formula yields 20 choose 0 is equal to 20 factorial over 0 factorial times 20 factorial is equal to 1. So,
in line with that, how many arrangements are there of the 20 people that involve one person ill? So, I think we can readily convince ourselves that there are 20 ways. The first possible sequence might look like this. The second possible sequence might look like this. And the last possible sequence might look like this. That must mean that there are 20 possible positions for the one I. Alternatively, we could use the formula for counting distinguishable permutations. The formula yields 20 choose I is equal to 20 factorial over 1 factorial times 19 factorial, which is equal to 20. How many arrangements are there of the 20 people that involve 2 people ill? I'm going to leave it to you to decide if you want to try to count this one out by hand. I can tell you that the first possible sequence might look like this. The formula for counting distinguishable permutations yields 20 choose 2 is equal to 20 factorial over 2 factorial times 18 factorial equal to 190 possible arrangements.